Good morning, students. Our next topic is pair of straight lines. So, in this one, combined equation of pair of straight lines. Pair of straight lines means about two straight lines. Okay, the combined equation of pair of straight lines. If L1 is equal to 0, L2 is equal to 0 are any two lines, then combined equation of L1 is equal to 0, L2 is equal to 0 is L1 into L2 is equal to 0. Okay, that means the product L1 into L2 is equal to 0. Next, any second degree equation in x and y represents a pair of straight lines if the expression on the left hand side can be expressed as a product of two linear factors in x and y. Once again, any second degree equation in x and y, any second degree equation in x and y, you can say in this form, some ax square plus 2hxy plus by square. So it is a second degree equation, but here it is a homogeneous equation. Homogeneous equation means for every term degrees are equal. So x degree 2, here xy, x degree 1, y degree 1, total 2, here 2. But that may be homogeneous, non-homogeneous also. Okay, in x and y represents a pair of straight lines. Represents a pair of represents a pair of straight lines means this one you can write as a combined equation of two linear equations. Okay, you can write as a combined equation of two linear equations. If that means if the expression on the left hand side can be expressed as a product of two linear factors in x and y. Linear factors means linear equations only in x and y. Okay, so that means when you want to say this second degree equation in x and y represents a pair of straight lines, means if you express this left side, what you have, x square plus 2hxy plus by square. Okay, so this if this expression on the left hand side can be expressed as product of two linear factors in x and y, that means here if you write this x square plus 2hxy plus by square, if you express as some y minus m1 into x into y minus m2 into x, actually it is a slope form for linear equations. Y is equal to mx, so y minus m1x, y minus m2x. Or another one, you can write some x plus m1y into x plus m2y. Then you can say this represents a pair of straight lines. Okay, so now come to the point, very important theorem. Prove that ax square plus 2hxy plus by square is equal to 0 represents two lines passing through origin, and they are ax plus h plus or minus root over h square minus ab into y is equal to 0. See, indirectly he is asking, this represents a pair of straight lines and find those pair of straight lines he is asking indirectly. So first we have to prove this passing through origin. Yes, very clearly, if it doesn't have constant, that is obviously passing through origin only. If you substitute x comma y as 0 comma 0, so x is equal to 0, y is equal to 0, if you substitute here you get 0 only. Okay, so it is obviously passing through origin, and represents two lines passing through origin, and they are, those two lines he is asking, ax plus h plus or minus root over h square minus ab into y is equal to 0. One line is ax plus h plus root over h square minus ab into y is equal to 0. Another one is ax plus h minus root over h square minus ab into y is equal to 0. So now we are going to prove this one. So given ax square plus 2hxy plus by square is equal to 0, very clearly it is passing through origin. So now we are going to finding those two equations. Okay, this implies if you entire equation divide with y square, what you have, a of x by y whole square. Actually entire equation divide with y square means x square by y square, that one you can write as x by y whole square, plus 2h xy by y square means 1y, in denominator y square 1y cancel, so we have x by y left over, so 2h of x by y plus b into y square by y square cancel, that means b only, plus b is equal to 0. So it is in the form of some ax square plus 2h x plus that means ax square plus bx plus c is equal to 0. In this form it is a quadratic equation in terms of x by y actually. Okay, so for the quadratic equation in terms of x by y, what are the roots? So x is equal to minus b plus or minus root over b square minus 4ac by 2a. If you apply that formula, so here x by y is equal to minus B means here 2H, A means A only, C means B. C means B. Okay, substitute here. We have minus 2H plus or minus root over 2H whole square minus 4 into A into B by 2A. Okay, so this is x by y is equal minus 2H plus or minus 4H square minus 4AB by 2A. If you take here 4 common, what you have? Here from 4 common and take outside, that gives 2 only. Okay, under root 4 is nothing but 2. So if you take outside, it gives 2. So from these two terms, if you take 2 common, we have minus h plus or minus root over h square minus ab by 2a. These two get cancelled. Now cross multiplication, y transpose to here, a transpose to here. Ax is equal to y into minus h plus or minus root over h square minus ab. So that means if you take minus common here, what you have? Minus common here, we have minus y of h minus plus. If you take minus common, plus becomes to minus, minus becomes to plus. Minus plus root over h square minus ab. Minus plus h minus plus root over h square minus ab is same as h plus or minus root over h square minus ab only. Okay, that gives same answer. So that means if you take minus common and transpose to right side, we have ax plus h plus or minus root over h square minus ab into y. Okay, this is why I am writing here. H plus or minus root over h square minus ab into y is equal to 0. So ax square plus 2hxy plus by square is equal to 0 represents a pair of straight lines passing through origin, and those two lines are nothing but ax plus h plus or minus root over h square minus ab into y is equal to 0. So based on this one, if you take one example, see here, the separate equations of the lines 6x square plus 5xy minus 6y square is equal to 0 are. So module 1 classwork from our material. Okay, so what he is asking indirectly, write the two linear equations of this equation. Okay, so what is the formula? For ax square plus 2hxy plus by square is equal to 0, ax plus h plus or minus root over h square minus ab into y is equal to 0. Okay, so here a is equal to 6, h is equal to 5 by 2 and b is equal to minus 6, because 2h is equal to 5, h is equal to 5 by 2. So separate equations are nothing but, that means the combined equations of this curve is nothing but, actually it is a second degree equation. Second degree equation is nothing but a curve. Okay, so this is nothing but, substitute here 6x plus 5 by 2 plus or minus root over 5 by 2 whole square minus 6 into minus 6 into y is equal to 0. If you substitute these values here, so 6x plus 5 by 2 plus or minus root over 25 by 4 plus 36 into y is equal to 0. So 6x plus 5 by 2 plus or minus this 436 are 144. Yes, 144 plus 25, 169. 169, that is nothing but root 169 is nothing but 13, and 4 is nothing but 2. Root 4 is nothing but 2. So this total we can write as 13 by 2 into y is equal to 0. Therefore the two separate equations are nothing but 6x plus 5 plus 13 by 2. Here 2 is the LCM. If you take first for plus into y is equal to 0, and 6x plus 5 minus 13 by 2 into y is equal to 0. That means it is 5 plus 13 by 2 is nothing but 9. So 6x plus 9y is equal to 0. From here 6x 5 minus 13 means minus 4. Sorry. Minus 8 by 2. Minus 8 by 2 is nothing but minus 4 into y is equal to 0. So total we have, if you take from here 3 common and transpose to here, after 3 we have 2x, here 3y. So 2x plus 3y is equal to 0. If you take 2 common from here, so here 3x and here minus 2y. So 3x minus 2y is equal to 0. These are the two combined equations. Next, nature of the lines ax square plus 2hxy plus by square is equal to 0. So nature of this curve. So is it represents a pair of straight lines? How it will be? Okay. So condition and nature. If h square minus ab is greater than 0, then the two lines represents two real and distinct lines. Real means we can see here. Okay, two real lines and distinct lines. If you take on the coordinate axis, those two real lines may be like this, because it is always passing through origin. So it is the origin. So like this, intersecting lines. Okay, and h square minus ab is equal to 0. If h square minus ab is equal to 0, then those two lines are nothing but real. Real means we can see. And coincident lines. Coincident lines means like this. 1 is on another. Okay. Next, h square minus ab is less than 0. So to imaginary lines you can't see. Otherwise, because it is passing through origin, just that represents as a point origin. Okay. So h square minus ab is less than 0 means two imaginary lines, or we can say point origin. Okay. So based on this one, you see one problem. The range of a, so that a square x square plus 2xy, it is 2xy plus 4y square is equal to 0, represents distinct lines. Represent distinct lines means what can you say? H square minus ab is greater than 0 according to this formula. H square minus ab is greater than 0 to real and distinct lines. If they mentioned without real, if they mentioned distinct lines, we can say same condition, h square minus ab is greater than 0. Okay, so here h is equal to 2 by 2, that is equal to 1, and this is 1, and a is nothing but a square and b is nothing but 4. Substitute here, h square means 1 square minus a means a square into 4. So 1 square minus a square into 4 is greater than 0. So that means 1 minus 4a square is greater than 0. So 4a square minus 1 is less than 0. So 4a square minus 1 less than 0 means, what can you say here? If you take 4 common, actually here greater than 0. So if you take minus common and transpose this side, so when you in the multiplication, negative number transpose to other side, so then inequality will be changed. So 4a square minus 1 less than 0. So if you take a square common here, and that means, sorry, here if you take 4 common here, so a square minus 1 by 4 and 4 transpose to here, 0 by 4 is 0 only. So this one you can write as a plus 1 by 2 into a minus 1 by 2 less than 0. So a actually, according to Wavy-Card method, it should be minus only in between. Okay, so that's why you just write a minus of minus 1 by 2 into a minus 1 by 2 less than 0. So here small number is minus 1 by 2, big number is 1 by 2. So represent on the number line. So minus infinity plus infinity, plus minus plus. Okay, so it is less than 0 means we have to consider minus condition. So a belongs to minus 1 by 2 comma 1 by 2. It is only strictly less than, so we have to write open brackets. Otherwise, if it is less than or equal to, we should write closed brackets. So it is less than 0 only, so we write open brackets. In other words, we can write this is minus 1 by 2 less than a less than 1 by 2.